right, we are at the top of the hour. Thank you all for joining us here. This second EcoFish webinar we're doing today. The first one was great. We had 52 people that joined from all over the globe, and we have a really good representation as well here this afternoon. So it would have been really interesting to kind of see a breakdown of what kind of participation we had and where, and maybe we'll still do that. But anyway, it does speak to the fact that this is of a lot of interest to a lot of you, and we'll kind of explain how it all works. Just in a matter of like kind of housekeeping, I've got my partner here, Ryan Sullivan. And Ryan's gonna keep an eye on the chat. There's also a Q&A section too, if you want to post questions there as we're going along. Ryan will do what he can to moderate those questions or just provide answers that he can answer, but also maybe keeping some of those in the bank for bringing up later. I want to try to leave some time at the end for questions. This is a smaller group this afternoon, so feel free to go off mute. I can't remember if we have to control that or if you can do that, but Ryan, they can. Okay, good. So anyway, yeah, we should have time to ask a few questions. This will go about an hour, and let's see what. We are recording this, and we'll either post this webinar or the previous one, whichever one went maybe a little, whatever one was the best of the two, we'll post on our YouTube channel. And so you don't have to like, be frantically keeping notes or whatever. And then also to anybody that participated, I'm going to send out a PDF version of this. And so if there's links in there or whatever, that you'll get those links. So, all right. So just a little introduction with me, a little background about me. I'm one of the founding members of the BioBase technology when it launched in 2010. So we've been around a little while now, but my education and early career experience was in fisheries. I was a fisheries research biologist with the Minnesota Department of Natural Resources in the early 2000s. And I've always had a passion for fisheries, and in particular, fish habitat. And how do fish perceive their environment? And how do they respond to it if it's altered? If it's altered, maybe that's a positive enhancement to the habitat. Or we are seeing a lot of the negative consequences of pollution and climate change and all of these things kind of conspiring together. So, and that's all affecting our fisheries. And so, but through my years, I've seen a huge gap between those doing fish stock and population assessments, and really, so there's a gap between, squeezing and counting the fish, and then, how changes in the environment are affecting what's showing up in the nets or in the creel. There's been kind of this gap, and we haven't really kind of put those two things together very well. That's just been my observation. And I think a lot of that is due to like we haven't been able to observe fish in their environment like wildlife biologists can observe critters in theirs. And we can't really see underwater, but that is changing with technology, right? And look at this cover slide. What we can see now from advances in sonar technology, low-cost sonar technology, is pretty amazing, becoming these virtual eyes underwater. So this is really the motivation behind BioBase and the fish layer, and that all kind of sets the stage for this webinar. Okay. All right. So moving along here. So the outline. I just want to give there are a few people on the webinar that have never used BioBase and maybe are unfamiliar with it, do a quick, we'll just get a one slide intro into what BioBase is. Introduction into the science of active acoustic detection of fish, just to kind of establish that context. How EcoView, our partner, I'll talk a little bit about our partnership with EcoView. How EcoView algorithms work to detect fish from consumer sonar. And it's a little confusion on the words, but it's EcoView is the company that we partnered with to create EcoFish, and some people have called it EcoFish, which also would be an interesting name for the product as well. But we went with EcoFish, so gotta try to keep all that stuff straight. But that's all right if you get those confused. We'll talk a little bit about effects of single beam and frequency on detection of fish of various sizes. There's some really, as we go along, I think you'll notice, hopefully it piques your curiosity. There's a lot of research questions. The technology is pretty new. There's a lot of research questions that still need to be asked and addressed, and a lot of research projects that should be a lot of fun. And so we're just kind of priming the pump and get people thinking about those. Yeah, we've kind of set the stage for really, I think, some growth and research. We're gonna I'll talk a little bit about teasing the fish aggregation apart from tree limbs and artificial structures that are either like in the water intentionally or just naturally there. We'll talk some various use cases and examples, and then we'll kind of close with the subscription packages and pricing and free trials and things like that. And then we'll have a little tour of the EcoFish outputs in the public BioBase demo account. We may run a little short on time at the end, but I'll just kind of show you where the demo account is. And the demo account's great because you can go in there and play around with data sets. You can pull data sets. You can kind of get an understanding of kind of the look and feel of BioBase and how it works. So, all right, real quick, 3-step process of BioBase. The essence is you're recording your sonar file. Right now we are exclusively compatible with Lowrance. However, we're actively working to gain compatibility with other device manufacturers. But as of right now, Lowrance is the Excel file format is what we process. Fortunately, Lowrances are pretty low cost and they're pretty nice. They work pretty well. So here's an example of just some seagrass, going over like an area of seagrass. You record that sonar file to a SD card. You create an account in biobasemaps.com. You upload that. Data is processed in remote cloud servers. You have algorithms that are identifying the habitat features. Before EcoFish, it was processing depth, vegetation, bottom hardness, and also in the last couple of years we pushed out a side scan layer. So you'll see some side scan examples in this presentation. But now we also have fish, and this is an example of the fish map, a fish heat map. Quote unquote heat map showing where aggregations of fish are, and this is an example where fish are congregating near woody habitat. So talk a little bit more about how this is really a great tool for seeing where fish are distributing themselves in the water body and how they might be responding to various habitat cues. All right, but first, got to establish context. This is a short 2.5-minute video. It's really good from the Gulf of Maine Research Institute. Kind of setting the stage with like what is acoustics? What is active acoustics? So let me see if I got this already queued up. Yes, I do. Ryan, let me know. Sound okay? All right.
My name is Adam Bacchus. I'm one of the researchers at the Gulf of Maine Research Institute, and I use acoustics to study marine organisms throughout the ocean. So acoustics can mean all kinds of different things. Passive acoustics is when you're listening to sound that's created by animals in the ocean. People might think about whale songs, or all kinds of fish and other organisms can make sound. You can listen to that and learn about what those animals are doing and where they are. The techniques we use are called active acoustics. We create sound using a device we put in the bottom of our boat called a transducer, and we learn something about the organisms in the water based on what sound gets bounced back to us. The two things we learn from acoustics are where things are in the water column and what type of animals they are. So where they are in the water column is determined from how long it takes the sound to get there and bounce back to the boat. And what they are is determined by how much sound they bounce back to the boat. If we think about organisms bouncing back sound to the boat, how much sound they bounce back really is dependent on what they're made out of. So a jellyfish that's made out of mostly water doesn't bounce back very much sound. But a fish that's made out of hard scales and has an air bladder in there is going to bounce back a lot of sound. So we can tell the difference between those two organisms based on how much sound is reflected back to the boat. Unlike some fish finders, our data doesn't show a little fish symbol when there's a fish below the boat. It just bounces back the sound, and it's our job to interpret that sound to figure out what species of fish are below us. To do that, we use a process called ground truthing. Ground truthing is a process of using nets and cameras to match the species of fish below the boat with the acoustic signal we see in the data. The ocean is a huge place, and it's filled with organisms in patches here and there. You can see a fish school over on this side, shoals of plankton down deep in the water, and there can be stretches in between with not much light. The advantage of sampling with acoustics is that we can do long surveys. The surveys that we do go anywhere from 40 to 60, 80 miles at a time. So that advantage is that we can see all of those areas, not just sampling one time at one place. Whether we're studying shrimp in the coastal waters or shoals of herring across the Gulf of Maine, acoustics is a powerful tool that we use in a lot of our research here at the lab.
Right. Thank you, Gulf of Maine Research Institute. All right. Cool. That's just a great context that kind of sets the stage and what we're talking about here. And then what we're doing that's unique with BioBase is we are, and kind of BioBase's MO up to this point has been leveraging and repurposing consumer fish finder technology developed for other needs, developed for the fishing industry into something useful for fisheries research and management. Marine electronics is a $6.4 billion industry because fish finders help anglers find and catch fish. And they've been helping anglers find and catch fish since the late 1950s. So I just kind of thought to myself, why shouldn't they also help fisheries biologists, researchers, and managers find and manage fish? It's not that big of a leap. And the fisheries profession, and I think maybe just because now these depth finders have become so, really sophisticated, they become almost like scientific devices, and they're really, really affordable now. And so it was the advent of side scan technology where the fisheries profession really kind of took notice and saw, hey, it's cool for fishing, but this is really interesting from a standpoint of mapping like river habitat. And so you had researchers like Adam Kaiser and Tom Litz that really, they published some seminal publications using Humminbird depth finders, and they were patching together screenshots of side scan and creating mosaics of side scan images to map fish habitat. BioBase also comes around about the 2010s. We were focused at that time on mapping aquatic vegetation and creating kind of these 3D, turning the fish, kind of the world of fish and fish habitat from 2D into 3D. That's really what also, these sonar devices give us, is really a 3D look at a fish's environment. So then, things develop with BioBase, and then EcoView has been around as a software company in Australia. They've been in the business of measuring fish with hydroacoustics for over 30 years. Their expertise is, like what the Gulf of Maine is doing with higher end consumer grade echo sounders and highly calibrated systems. They really refined the technology to do fish stock assessments with, big acoustic survey systems. So they've refined that a lot over those years, and the science now is pretty mature, and there's a growing demand for processing consumer sonar files. BioBase is really the industry leader for automated processing of consumer sonar. So kind of all these things came together. Companies teamed up. We took a look at our workflows. We tweaked some algorithms, and we released a product on May 19th of 2025, and EcoFish was born. All right. So we can start to get kind of into the nuts and bolts of EcoFish and kind of how it works. So on the left, you see that this is just a raw sonar image, and these are fish arches. Most of these are fish. However, sometimes these little arches could be, macroinvertebrates. It could be insects. It could be large zooplankton. And then you have these big bait balls that are schools. So what EcoView did, and what EcoView does, and they've been doing this for years, is they take this is just a raw image of acoustic backscatter. This is raw, like, energy. And the hotter the color, the hotter the yellow, the more the backscatter, the more the energy, probably the bigger the fish. And so it's identifying then as pulling out these things as objects. So here this yellow is the school, and the blue is the individual fish. I'll talk a little, yeah. So EcoView's processing workflow applies image segmentation techniques to classify the data into exclusion zones that are either near the surface, too near the surface to detect fish, or they're connected to the bottom, and they isolate those exclusion zones from suspended targets. So anything that is in the orange here, the orange has a significant amount of backscatter or energy return that is probably either a fish or a school. And these and the faint or green arches may be small fish, or, like I was saying before, insects or zooplankton. Or also we're talking about, so consumer sonar generally, and you may see this changing within the next 3 to 5 years. We may develop split beam systems. There is a demand for that, but maybe the costs still need to come down a little bit. Anyway, they're single beam systems, meaning that that fish on the edge, you could have a large fish at the edge of the cone, and it's going to look acoustically small, versus if it's in the middle of the cone, it's going to come back and bounce back a lot of energy. And so so fish at the edge of the cone could be one of these little arches. We aren't totally sure. But then you also think about these systems ping at 20 data points per second. So if you're going at a decent enough speed and you've got a pretty decent, and these fish are moving around, right? And also think about, you're taking a sample. You're not taking a census. You're taking a sample. So at the end of the day, I'm not too, granted I'm biased, whatever, but I'm also, if I'm just to put my research hat on, I'm not too concerned about those fish at the edge of a cone, because it's like you're gonna get them. You're gonna get them one way or the other. So anyway, that's just something to keep in mind, that you could have a large fish at the edge of the cone. It's gonna look small. All right. So EcoView does all this stuff, and they pull out these objects. And so this also, though, did cause us to ask some fundamental questions about, well, what's an individual versus what's a school? Is 2 fish a school? Is 3 fish? Where do you make that delineation? So we kind of found a Goldilocks method, and it seems to work. So, but that's, having said that, we pushed out, version 1. We're at 1.0, and some of the stuff could change as we get more and more, as more of you use this, and you're providing feedback on what you're seeing. Right, and we're going to go through some of these cases. We're going to go through some of these cases, and you're going to have a lot of questions, right? Well, how about this? Like, how does it see? What happens if a fish doesn't have a swim bladder, or those kinds of things? Like, those are good questions. Those are good questions. All right. Fish size, or we call this we call it an immensity metric, for lack of a better word, but it's like it's an acoustic size. So here's an example of a large fish. It's a very hot yellow color, a lot of energy return, a lot of back scatter, um, and we have a value. There's a value that is that, and I'm going to show you the data exports. You will be able to see these values. This is in black box. You'll be able to take these values and do your own kind of analysis, and again, give us feedback on what you're finding. We did based on our understanding, our knowledge, and what we have in our limited amount of data from other like beta testers. We found breaks at this 0.32, medium immensity would 0.25 to 0.32, and then small immensity, which maybe is an oxymoron. I don't know, maybe we need to change that word. But anyway, that's 0.25 to 0.32. Again, I'd like to, and you might find different breaks based on your research. I could see, if you're working with a very simple fish community, I could see us, working with you and really kind of dialing in that, okay, well, we found, we only have 2 different kind of size classes of fish in this fishery or this pond, and this is what we were getting back in terms of this immensity value. So I'm looking forward to working with you all on that. Now we can kind of move into, we're showing you the cross section images. Well, now what does this look like on kind of a, I guess a 2D surface, but really kind of, we're working towards kind of this 3D understanding. But how do we kind of create a map of this? So this is one feature, you get a heat map. The purple is where there was no fish, or these are excluded zones. EcoFish doesn't work in anything less than 1 meter. We're just not confident enough it's just not enough target separation between the surface and the bottom, or so 1 meter below the transducer. We're just not confident enough in those, there's too many false detections in that zone. It's a very high energy zone. So we just blank that out. So that would be an exclusion zone. Or where vegetation is greater than 75% biovolume. That's vegetation that's almost going to the surface. So it's like, no, for all, and I'll show you actually a heat map of vegetation on this one. We can look at that a little closer. Where was the vegetation? If this was all vegetation down here, we would say, because then that's excluded, then that's not going to be analyzed. So the yellow is going to be where there's aggregations of 10 or greater, or where there's a school. School, we just give it a value of 10. And then anywhere these spotty green dots are like individuals. These are binned in 5 meter intervals. So every 5 meters we do like, okay, how many fish was in this 5 meter by 5 meter area? We summarize it based on that. We also have the individual fish detections, and we have them listed here. And we have this decluttering algorithm that in the UI that as you zoom in, it will declutter and declutter. Because sometimes there's so many fish that if you try to like render every pin, it would crash your browser. So where you see these little sonar, these little transducers icons, that will it has a list of those fish at the various depth. It should also say, yeah, like when we talk about large, medium, small, we don't know what those sizes are. We don't know in terms of inches or millimeters, centimeters, whatever. We don't know that yet. Again, that's something I think that would be up to research to kind of to figure out and get us some of that feedback. Here's the icons. If there's just a single fish, that's yeah, that gets a little fish icon here. A single school has this little group of 3 icons. And what's kind of nice about this, you can view this on top of other habitat layers. We also have Google Earth that you can export KML or KMZ. And there's just an example of a stormwater pond and the kind of cool quasi 3D rendering in Google Earth. And that's a great way if you want to share that with colleagues or other clients or whatever. You can zip up those Google Earth files and send to them. You know, as I'm talking about this too, you're probably gonna be thinking at the last meeting, people were asking about kind of the angling angle, like, and thinking like, oh man, there is so many cool things that we can do from a standpoint of understanding where fish are, their behavior, and how I can find and catch fish. Everything that we're talking about here is focused primarily on research and management. But it has so much potential too from the fishing side of things that we'll probably be going down that road, not, you know, in not too long. So we can kind of chat more about that later in Q&A. Automated reports, it creates as users who use BioBase understand, like, you know, how valuable these automated reports are with the vegetation and water volume and all that stuff. This also gives you a summary of the fish, how many individuals were surveyed, how many were in each one of these categories, how many schools, what was the depth range. And I'm going to come back to this example in terms of when we do the habitat discussion. This is a 2-story fishery. What a 2-story fishery is, you have warm water fish that are occupying generally shallow water zones. Warmer water, we're talking, you know, a lot of your centrarchids, your, you know, bluegill and bass. And then the colder waters, the conventional 2-story fisheries in the US anyway, inland US, are trout fisheries, where you have trout that are occupying colder water zones in the lake. And these two, they really segregate themselves. And so this is a great way we can look at where are those zones. And we're going to talk a little bit about as maybe some of you who manage pelagic fisheries understand kind of this concept of you know, kind of the squeeze in the summer of, you know, the temperature and dissolved oxygen can kind of squeeze these fish. So this is another great tool to see when are these fish getting squeezed. I'll show you a little bit more on that later. So also creates a CSV data export of every individual fish that is detected, the depth at which it was detected, latitude and longitude, and then that size classification and that immensity value, that kind of that backscatter dimensionless value. So it's very powerful because you can just take this, if you're a GIS person, you can take this data, you can do your own kind of analysis, put this in your statistical software, and you can have fun with it. Okay, so those are the high level explanation of the features. And this was kind of a fortuitous, I kind of stumbled into this, which that's what makes technology actually just so fun, or research fun. Like sometimes you just stumble into things that like, oh, that's weird, that's interesting. And this was kind of one of those cases. I did not set out to evaluate this question. So if I was designing a research study to evaluate this, maybe I would have done something different. But I'll show this. I'll show you what I did. But just some context here. The frequency of your sonar unit is a key fishing strategy, and their beam angle and frequency, they combine to give an angler a range of options in finding fish in different types and depths of waters. In the last 10 years or so, you're hearing more and more this concept of chirp. And what is chirp? Chirp, it's abbreviation for compressed high intensity radiated pulse. So, and this is a great schematic from West Marine, and down here is a schematic from Airmar. So what chirp does is it sends out varying frequencies and a longer pulse duration, and then as a result you get, in this, it maybe is a little harder to see, but you get better target separation from individual fish, whereas this is a traditional frequency, and they're more kind of blobs together that might actually be, like in this case, maybe this would be considered a school. But in this case, I bet, and this would be a really interesting, kind of have the data to show this, but you might find if you're running just a single frequency, maybe you're getting more schools picked up versus here you're seeing more individuals. That would be just something that would be interesting to kind of look at. One of the other things that we found with the chirp, so chirp is getting to be pretty popular for angling. It's still it's still kind of under research and development on our side of things to know like what does it do in terms of mapping. There's some evidence of poor penetration of dense vegetation canopies, so it's harder to track depth in with using like high chirp. So generally what we have found is that 200 kilohertz is kind of the Goldilocks single frequency, and it's still, as of until we really kind of learn more. And if you have to kind of choose one frequency, I'd probably still go with 200 kilohertz, unless you're working in deeper waters. Then deeper waters deeper than 30 feet, then maybe 50 or 83 kilohertz or medium chirp. Still a lot of experimenting that needs to be done there. So the theory underpinning this, and we'll kind of go quickly through this. I don't want to belabor it too much, but aquatic organisms reflect back sound differently depending on their size and body composition. If they have do they have a swim bladder, or do they not? What size are they? Your small insects, mayflies, midges, mysis, shrimp, other aquatic insects, they're not going to be visible until your higher frequencies. So really not until 200 kilohertz, high chirp, okay, they start to become a little more visible there. Fish with swim bladders, they are pretty visible at a range of frequencies. Fish without swim bladders, again, another interesting question. I have a paddlefish and sturgeon conference that I'm going to in British Columbia in September, and it'll be, I don't know if the Kootenay River, I don't think it has paddlefish, but that's where it's going to be. Anyway, if anybody does work with paddlefish, I'd be really interested to see what that looks like on the in the file, and how that would reflect back sound. Except paddlefish apparently don't have swim bladders. So, all right. So it always is a challenge when you have multiple organisms of different acoustic types and sizes. If they're present, it can get a little more complicated to kind of tease apart what's what. All right. The thing that leads into these next slides, lowering the frequency, it may help filter out small fish targets if your study objective is to detect only adult or larger fish. Something to keep in mind. And here's where we'll walk you through some visual examples. This was, I was just doing some repeated testing, I was actually testing I was just testing the Lowrance software update. And so all I did to do that is I was running different frequencies. And I wasn't running them at the same time because you don't want to have multiple transducers running at the same time because they'll interfere. So I would, record a sonar log. You know, I'd start it here, stop it here, and then I'd turn around, I'd come back, start it again at a different frequency, and rinse, wash, rinse, repeat. Here is there's a lot of fish, you can see a lot of fish in the sonar image there. This is high chirp. And then here, the blue is all the fish detections. And here's the report. It detected 168 individuals, most in the small and medium categories, a couple of the larger fish. But here, yeah, so 168 small and medium. So keep that in mind there. 200 kilohertz. So the frequency went down just a titch. It's not a one-to-one relationship again with chirp because chirp is sending out multiple frequencies, but I think it's kind of overall a lower frequency. And here you can see 54 individuals detected, so fewer individuals. And here you can say there's fewer blue little circles there. Mostly small, medium. Didn't pick up any large fish, but I mean, it's hard to know. Was that different than the high chirp? Probably not. That number, I mean, who knows? So medium chirp, and that's going the next notch down in frequency. Look at how fewer detections there are, and it was only picking up the large fish in this case. And then here's 83, about the same as medium chirp. Again, only the larger fish. So I finished this up and heading back in, and I think I did another sonar recording as I was coming in, and I didn't at the time have the presence of mind to record multiple frequencies, but so I encountered this where there was this part of the river had an emergence of something. Maybe there were mayflies, probably mayflies that were coming up from the bottom. And here you can just see, like, look at all of these detections. They are a bunch of individuals, and some of them came out as schools. And but you can also see some larger fish maybe feeding on some of those mayflies or just kind of hanging out on the bottom there. But using the high chirp, we sampled 104 individuals. Almost all of those were in that small category. Again, they're probably like insects of some sort. Medium, we had, and then 9 medium, and then there was 1 large guy, which was probably this guy right here. So the moral of the story is here, perhaps increase the, actually this is a typo. Decrease the frequency to punch through insects or the thermocline to be able to just see the large fish. So I'll correct that on the PDF I send out. All right, so now moving to artificial habitat. This is another thing that we found that still needs some research and development. But this is something that's got, I mean, there's a lot of this going on in the fisheries industry, and you see like the growth of all of these, and really especially in reservoirs and ponds and lakes that just don't have a lot of natural habitat, like so the artificial habitats is all they got. And so you're seeing, and it really makes a big difference for enhancing a fishery. So here's an example of what the Ugly Tree brand looks like. Here's here's that traditional sonar. Here's a down scan, gives a little more definition of those tree limbs. Now, where are the fish? Well, this might be a fish, these might be fish, but if there's fish underneath any of these limbs or kind of right in the middle of it, it's going to be hard to be able to tease that out. So what you get in return is something like this where, okay, well, this thing right here, this thing, whatever this thing is, it was probably the top of that ugly tree. It's probably the actual physical structure. But you can at least, though, you can see here, it's, again, very visual product. So you can see like, okay, no, I definitely see these fish that are using this, right? This is a fish object here, fish object down here. These fish will have an acoustic size to them. So even though there is some false detects, there's still a lot of like useful data that you can get there. Georgia cube is another kind of fish habitat structure. Here's what that looks like in the sonar. Here's what EcoFish looks like. Again, here are some individual fish that are kind of hanging around the structure. A mossback habitat, very popular, also another popular type of fish habitat, artificial habitat. Here's the regular, the broadband traditional sonar, the downscan, and then here's what that looks like with the EcoFish. A handful of fish that are using the structure. Okay, moving quickly and kind of covering a range, kind of, blasting through a lot of different topics, but these are all things that are kind of those frequently asked questions. So, and there's gonna be more frequently asked questions, but these are the first frequently asked questions. Transect design, we did a dedicated webinar on that a couple months ago, really well attended, but that was focused on transect design, doing, bathymetry mapping, aquatic vegetation, and so that's kind of a different beast compared with fish. Fish are moving around, they swim, and so, could we use the same design? And maybe we can. The only thing that I probably wouldn't recommend though is something like this. I'd call this kind of a plate of spaghetti, where you're going all over the place, and the intent here, I understand the intent is like, let's just say it's a very complex bottom topography, and you want to really kind of really cover it really well to get an understanding of the bottom structure. The hard thing is when you do that with fish, you're double, triple counting fish. Like I said, one of the features is BioBase will give you an export of the individual fish detections. It will also give you a report that gives you a summary. Hey, this is how many fish detections that was in the file. Well, you can intentionally cheat it, right? If you keep going back and forth over the same area, you can artificially inflate your numbers. So that's why it's kind of good to stick with just kind of a good a design like this. This was actually with a USV, so you can see how crisp that is. This is really this is almost overkill too. But it's kind of a concentric circle design. You could also probably use, a back and forth transect design. Those are always great. That's always a great, fail-safe way to do surveys that are going to kind of cover the range of multiple objectives. So, but yeah, in general, I wouldn't do this, and yeah, this is better. All right, map verification tools. That's another thing about BioBase. What we kind of always sell, if you will, is that this isn't a black box product. And this is kind of unique to a lot of other mapping platforms. I mean, it gives you this sonar image, and it gives you the ability to, like, okay, here is you can click on the sonar image. It will highlight the depth that was there, or the vegetation, and it'll give you a timestamp where that exactly was, and it will put that little yellow dot on the map. So it's very visual on what's going on and what is where. So what you can do to verify the output is you can go to Tools, Export Data, Export the CSV data. And this is just a little excerpt from the Excel spreadsheet here. And this is just an image of where we can, let's kind of identify that. This is an example of finding out like what is this fish? Is this a big fish? And where is that? And we could find that in the Excel file. That was right here. There's that immensity score. And so in this example, what we are going to pair up is the timestamp. The timestamp is very diagnostic. That timestamp is in the CSV file. That timestamp is also here in the data file, and that's matched up. And really, the timestamp is really the unifying theme in this whole thing. And if that timestamp is corrupted in the file or it doesn't have an embedded timestamp, it's harder to, you can't really do much of this this mapping. So anyway, what we can do is, again, we can just pair all that stuff up and we can see here's that large fish. All right, now we get to the kind of the fun research fish behavior stuff. Started out the talk with this image, but this is a kind of a dedicated slide, a dedicated kind of chat about fish orienting to habitat, and habitat meaning contour structure. Sometimes, like anglers get this for whatever reason. I mean, I had a researcher I worked with when I was first starting at Minnesota DNR, and I'll forever remember. I'm kind of pretty green, and he said, Ray, just remember, fish do as they damn well please. And I'll remember that, and many fish researchers will appreciate that. Like sometimes you don't understand why, but they do as they damn well please. Anyway, so sometimes they are orienting to certain structures. You don't know why, but there are certain depth structures that they like it there for some reason. This gives you an eye into that. This is not rocket science. They like wood. That's not rocket science, but sometimes, yeah, there's just like, I don't know why they're there. They're just there. Here's an example of the side scan and showing like a rock outcropping, and and then here's a fish along the track. And so maybe they you can see them orienting to some habitat structure that's just kind of shown by the side scan. It's all in one file. We're not talking about multiple different files here. This is all in one file. Aeration systems, right? How is the aeration? A lot of pond managers use aeration, and how is that? How are the fish responding to that? Where are they in the water column or in the lake or pond? Are they responding favorably to it? This is another example of fish orienting to woody habitat, this mixed with aquatic vegetation. And this is pretty cool because you can actually see there's schools of bait fish. And then you can see some of these individuals, these larger individuals, almost like orienting to prey, right? And you can see them all kind of by these bait balls. So that's a pretty interesting information. I guess one of the coolest examples that we've seen so far is, and this is a big issue. It's a big issue with our cold water fisheries, especially in marginal habitats, where you're seeing a lot of these lakes become degraded by nutrient like eutrophication, climate change. I mean, all of these things kind of conspiring together. And what happens in these cold water fisheries, like your Cisco lakes. Cisco are a critical cold water prey fish. Trout lakes. This decline of oxythermal habitat in the midsummer squeeze, and that is, you got warm water, high oxygenated water on the surface, and that over the summer starts to go down and go down further. You have cool but less oxygenated water in the hypolimnion, and that loses more and more oxygen, and so the oxygen levels, that critical oxygen level starts to go up and up, and it's just that thermocline. And that's another thing is these depth finders do kind of map that denser water, that thermocline. And so we could actually, and it's so easy to collect the data, right? You could go do multiple surveys throughout the summer, say, and you could almost get perhaps predictive models. Are we going to see a fish kill this year? And you could see kind of in real time these fish getting squeezed. So that's that's pretty cool stuff. I'm excited to kind of see how that develops. Same with with this automated report, we talked about this, these clear bimodal distributions with this, in this case, this 2-story fishery. So what is happening to this zone? And I would imagine that this mode is going to be shifting farther and farther to the left, but then at some point it gets too warm. So pretty interesting stuff. And some of this stuff makes me want to go back to fisheries research, but the technology's fun too. Fish and aquatic plants. This is actually, this is kind of one of my soft spots as well. With anglers, they know you often see fish on the edge of vegetation beds. And this does a great job of showing exactly where those fish are. So here is your heat map. And then look at how well these fish just line up with the edge of that vegetation. What happens when you have an invasive species come in? What happens is that as that shifts out, as that moves in, what are these fish doing? What are they doing at different times of the year? All of these questions. What does it mean? Right? It means something. But maybe we don't have the answers yet, because we have to really kind of get an understanding of just a straight up documentation. This is what they're doing. And then from that, we can kind of start to ask then why. Custom GIS analyses is another great, this really easy data to be able to do this, where you can filter the CSV data by depth and then map fish different depth strata. So this is an example of a disappearing Cisco population in Indiana Lake, an endangered Cisco population. What the Cisco seem to be kind of hanging in there. And here's an example of if we hear, we have different symbols by the large, medium, and small in the school. So we could do like these GIS maps. Okay, just think of the fisheries questions you can answer. We didn't talk about this yet. Did the lake or pond have a partial or complete kill? Maybe summer kill or winter kill. Maybe that's desired. Maybe that's not. How much fish are using the habitat I added to the pond? We talked about that. Production depletion, aeration. Where are these fish concentrating in stressful periods? Then this was an example brought up when I was talking with a UK customer at the Environment Agency, and talking about how avian predation is a big issue in some of their inland lakes in the UK. And they have seen evidence that it increases schooling behavior, anti-predatory response. Okay, subscription packages and pricing. So I didn't talk much about EcoFish. You have EcoFish, which is this new product, and then you have EcoSound. EcoSound is the traditional BioBase mapping layers. And on our plans page, we kind of have this good, better, best thing based on usage and features. And they're priced at different levels. And you can add EcoFish onto any one of those mapping subscriptions. We have one-offs if you just want to, if you're a service provider and you want to just kind of write this off or pass the cost off to your client with billable hours, you can do that. Or we have the subscription pricing. We have free trials. If you're new to BioBase, you can get the EcoSound plus EcoFish free 30-day trial. It's a pretty good deal. If you again, if you're a service provider, you could then, this would be free trial for you, and could be a good way to dip your toe in without any risk. We sell the hardware too. We sell portable kits, portable Lowrance kits, and we actually have some bundling deals that if you bought the portable kit, you get 25% off the EcoSound, Habitat Plus subscription. If you're old, so you're new to BioBase, get the free trial. If you're old to BioBase, you get 3 free sonar files processed for fish. You just let us know. We have a Microsoft form, so we will, that link can send out that PDF. You can click on that link, and then you can suggest. You can put in there. Yep, I see Ryan actually put in the chat that link, and then you can. Hey, I've got these, these files. They look like they've got a lot of fish in them. Can you process those? So there's the single one-off EcoSound one-off plus EcoFish, $12.49. And then there's, if you just wanted to do just an EcoFish, like let's just say you have an unlimited EcoSound subscription, and you just want to do, I just have this one isolated survey for fish, then that would be $750. That would be the $750 for the one-off. So I actually should have promoted this bullet over to here. EcoFish one-off. Okay. Unlimited EcoFish subscription add-on is $2,500 in the US, UK, and Canada, and we have discounted rest of the world pricing. So if you're outside of those regions, let us know. We'll work with you individually on that, and we have a standard kind of discount matrix on that. So, and then there's this 25 to 50% discounts if you're adding that subscription, adding the EcoFish subscription on to your EcoSound subscription midstream. Discount that. Historical sonar file processing. This is something that we're getting more and more requests to do, and we're just in the midst of figuring out a fair pricing model on that, because there is real costs for us to spin up these servers and run the algorithm, and and so we have costs there too. And so if you're just doing like kind of a one-off thing, it's $99 for a handful, or dozen files or whatever. But if you have more than that, talk with us, and we've kind of developed kind of a pricing, kind of a fee schedule on that. Yep, like I said, yeah. Some quote there. And plans reviewed at biobasemaps.com /plans. Okay. So we're gonna jump real quick to the we're not gonna spend too much time in the demo account, but just want to show you around a little bit, and then we'll open this up for questions. If you're interested in kind of learning more about the history of BioBase, we are on the Fisheries podcast, actually 2 different podcasts in 2022 and 2025, and I talk more about EcoFish in 2025. So. All right, so that's that. We'll jump out of the end slideshow, and yeah.
So we do have a question. It is, can the depth exclusion zones be lessened if you use a side scanning method instead?
So are you pointing the traditional down, you're rather than it being down looking, you're saying looking to the side? Oh yeah, possibly. Boy, that would be don't expect much. It could work, maybe. So yeah.
If Ali is still here, maybe she wants to unmute and extrapolate a little.
Elaborate or extrapolate. No, she would be there would be some extrapolation going on there. All right. Well, so yeah, so anyway, while we're waiting for that answer or to the next question, I kind of went kind of quick, but just the homepage biobasemaps.com, we go to log into demo here, and let's just go quickly to a trip. You click on trips and merges, and let's look at, we talked a lot about inland lakes, but people forget that BioBase also works in the coast for seagrass and kelp mapping as well, and fish mapping here. So let's see, the South Pacific and off the coast of Chile, Chilean kelp. And we'll just show you really some cool stuff there, and then we'll wrap it up. So here's an example of, here's your map that comes up, your depth map, your different layers. Let's look at vegetation first. All this stuff is the kelp that's growing on the bottom there. But there's a lot of fish. As we scroll around here, you'll see there's a lot of these little fish things here. To track off. So just kind of take a mental note of where this vegetation is. And then we're going to go to the fish abundance now, fish map, and look at all of those fish right on the edge of that kelp for the most part. And we're going to click on this. Here is the EcoView image here, and look at all these fish in schools all around by that vegetation. Pretty cool stuff there. Here's where you look again for exporting all your data, and yeah, the different layers, fish targets. Yeah, so there's like this cool opacity. If you're looking, you want to look at like the rocks nearby. Turn on that opacity tool. So anyway, that's what I got. I think we're at time. If anybody wants to stick around, is there any other questions that came in, Ryan?
That was it.
That was it.
Unless we
Okay.
have somebody wanting to ask one now.
All right. Well, thank you all for joining, and we'll button this up, and we'll be sharing one of the webinars. On keep an eye on it. The YouTube channel will send out an email with that link. Okay. All right. Have a great night.